Hello everyone. In the last video lecture we talked about the solution of boundary value problem in unit call. So today we will start with uniqueness theorem by the energy method. So what is the theorem? If there is a boundary value problem, we consider it is delta of u equal to minus of f in u and u equal to g on the boundary, then there exists at most one solution u which is in c square u bar of this boundary value problem. Okay, so you have to show that there exists at most one solution. So let us suppose that if possible I take two solutions, u and u tilde are the two solutions of the given boundary value problem. So now I will prove that our supposition is wrong. So by the contradiction we are going to prove this one. So we define a function w is equal to u minus u tilde. As we are considering here u and u tilde both are the solution of the given boundary value problem. So if u is the solution of the boundary value problem, so what does it mean? That means delta of u will be equal to minus f in u. और अगर u tilde भी solution है, so you will say that delta of u tilde will be equal to minus of f in u, right? So that means if we take delta of w, that will be equal to delta of u minus delta of u tilde. बट ये भी सोल्यूशन है, ये भी सोल्यूशन है, तो इसकी वैल्यू क्या है? माइनस एफ, और इसकी वैल्यू भी क्या है? माइनस एफ. सो माइनस ऑफ माइनस एफ, दैट विल गॉट जीरो. सो डेल्टा ऑफ डब्ल्यू वी गॉट जीरो इन यू. नाउ वी टॉक अबाउट ऑन द बाउंड्री. Now if we talk about on boundary, so w is what? It is u minus u tilde, but u is also a solution of 1 and u tilde is also a solution of given boundary value problem. So that means u भी किसके इक्वल होगा? g के इक्वल होगा बाउंड्री पर, और u tilde भी किसके इक्वल होगा? g के ऊपर होगा बाउंड्री पर, क्योंकि दोनों सॉल्यूशन है गिवन बाउंड्री वैल्यू प्रॉब्लम के. सो दिस इज g, so that will be equal to 0. So w becomes 0 on the boundary. So what we got? डेल्टा w 0 है u पर और w क्या है? 0 है on the boundary. So we have this one. Okay. So now if I take integral over u, so w into delta w, that will be equal to 0. Alright, because both are 0 in u, तो अगर w and delta w if we are considering, so we will take that delta w into delta w dx, that will be equal to 0. Alright, now from here you can say that delta w is 0, that's why that will be equal to 0 always. Now you have to remember this formula 1. That will be useful, and that we will use in further theorems also. So what it says that integral of u into delta v in capital U, that will be equal to u into curl v over curl nu over the boundary, where nu is the unit normal vector outward to the drawn outward to the region. Okay, and minus integral of du into dv over the u. So what is this one? So that means you have to remember in this way, when we are talking the integral of u into delta v in u, okay, so that will be equal to integral over the boundary minus integral over u. First of all, remember this thing. Then in this way you have to remember, first is u and second is delta v. So we will write down that over the boundary, that will be u as it is, and that will be curl v over curl nu. Over the boundary we are taking, so that will be ds. Then minus, when you are taking integral over u, so you have to take derivative first u into derivative of second v, so du into dv. Okay, in this way you have to remember this one. So that will be useful, and that will be further we will use in the next theorems. So over here what we have w into delta w in u. Okay, so we are applying that integral over the boundary of u minus integral over u. So when you are taking integral over the boundary, that will be first function w into second function, it is curl w over curl nu ds. minus when you are taking integral over u, that will be derivative of first function and derivative of second function. So dw into dw, right? Dx, dw dot dw. So now we know that delta w, w into delta w ये क्या है? 0, because delta w आपका क्या है? 0 and u. So that will say that this integral is 0. I will say that this is 0, and this minus this I will get, right? Now that can be written like this. Okay, now we can see that this w is 0 on the boundary. Above we have shown that w is 0 on the boundary, so that means this part one 0. So if w is 0, so you will say that left hand side of 4 will be equal to 0. If this is equal to 0, so you will say that that part is 0. If this part is 0, so I guess say that integral of mod of dw square over u, that will be equal to 0. So I will get this one. Okay, now we know a theorem: if f is non-negative on some a, isn't it, and integral of f over a is 0, so that f will be equal to 0. Okay, so over here also this term is non-negative in u, and integral of this term over u is equal to 0, so you say that that term will be equal to 0. That means mod of dw square will be equal to 0 in u. If mod of dw square is 0, so that means mod of dw will be equal to 0, or you say that if mod of dw equal to 0, so that means dw will be equal to 0. Okay, mod of x equal to 0 implies x will be equal to 0, right? So now dw equal to 0 in u, what does it mean? That means derivative of w is 0 in u. Okay, if derivative is 0, so that means w will be constant in u. So you can say that w is constant in u, and we know that every constant function is continuous, so we will say that w is continuous in u. Okay, also we have shown that कि delta of w क्या है? 0 है u पे. So that means u satisfy the Laplace equation. If you satisfy the Laplace equation, so you will say that w is harmonic, right? So w is continuous and w is harmonic. So what you have to show here now? So now you have to show that w is 0 on the whole u. W is 0 in u bar, you have to show actually. W is 0 in u bar. You have to show this thing. So what I take? This is 0. So what I say? I take some arbitrary point in u bar. Okay, I take a belongs to u bar, be any point. Now since w is continuous, and by the definition of continuous we will say that as limit x tends to a, then wx will be equal to w of a. Okay, right? So if I show that this w of a is equal to 0, अगर हमने ये show कर दिया w a 0 है हमारा, so what I say that for all x tending to a, w of x will be equal to 0 हो जाएगा. Okay, so that means that w will be equal to 0 for all x belongs to u bar, right? So that thing you have to show that w of a equal to 0. So what I take here, हमने कहा है कि a belongs to u bar, so I say that a is on the boundary of u. So when the a is on the boundary, but we know that on the boundary w is equal to 0 on the boundary. Okay, so whatever the point I take on the boundary, so that w of a will be equal to 0 on the boundary. So I will say that w of a will be equal to 0 on boundary, right? So suppose that if I say for the instant you consider, means in such a way you can consider somewhere there is a point over here a, that is a boundary, and somewhere if you are taking some x in u, right, when this x is approaches to this a, when this x is approaches to a, so that means w of x, that will be equal to what? That will be equal to wa, but wa क्या है आपका 0 है. So that means you will get when x is approaches to a, that value will always be equal to 0. तो हम सभी के सभी x को अप्रोच करा सकते हैं a पर, ओके, बिकॉज w इज continuous, so that when x is approaches to a, तो wx किसको अप्रोच करेगा, wa को, और wa आपका 0 है. So in this way we will say that w of x when x approaches to a, that will be equal to w, and w equal to 0 for all x belongs to u, राइट. और जब ये x हम बाउंड्री पर लेंगे तब तो आपका 0 है ही, राइट. सो दैट मीन्स व्हाट वी गॉट हियर, w आपका 0 आ गया ऑन u, right. Now if w is equal to 0 in u, so what was w? W was u minus u tilde. So u minus u tilde is 0 in u, so that means u will be equal to u tilde in u, okay. And we have already shown that कि हमारा बाउंड्री पर तो w 0 ही था, तो w 0 था, तो यानी कि u minus u tilde equal to 0 on the boundary also, okay. So अगर बाउंड्री पे भी 0 है, u पे भी 0 है, so that means on the closure of u I can say that w will be equal to 0, okay. So w will be equal to 0 on closure of u, so that means you can say that w will be equal to 0, that means u minus u tilde equal to 0. What does it mean? That means u will be equal to u tilde on the closure of u, okay. So we have shown that as you assume that u and u tilde are the two solutions of the boundary value problem, they are actually not the two different solutions, they are the one, okay, because both are the equal. So that means there will be only a unique solution of the given boundary value problem, right. So next we have Dirichlet principle. So what it says, so Dirichlet principle says let u belongs to c square u bar be any solution of the boundary value problem, and this is the boundary value problem. Delta u equal to minus f in u and u equal to g on the boundary. अगर u इस boundary value problem का solution है, then u is the minimizer of the energy functional capital I, okay. And what is the energy functional? Energy functional is this one, हम इसे इस तरीके से डिनोट करेंगे, I of w will be equal to integral over u half of mod of dw square minus wf dx. So इस तरीके से हमारा डिफाइन है कि एनर्जी फंक्शन हमारा ये होता है, ओके. सो अगर u हमारा गिवन बाउंड्री वाले प्रॉब्लम का सॉल्यूशन है, तो हमें ये शो करना है कि u इज द मिनिमाइजर ऑफ दैट I. So what does it mean? That means you have to show that capital I at u will be equal to minimizer of the IW for all W belongs to A. लेकिन A क्या है? A है हमारा set of all those two times continuously differentiable function which is equal to G on the boundary of U. Okay? So that is A. So जितने भी ऐसे W है, उस W पर हम IW की वैल्यू निकाल लेंगे. उन IW की वैल्यू पर सबसे मिनिमम वैल्यू जो हमारी क्या होगी, किसकी होगी, I of U की होगी, right? This thing you have to solve. And what will be its converse? Its converse will be if u belongs to A, this is A. अगर u इस A से बिलोंग करता है और इस इक्वेशन को सेटिस्फाई करता है कि आई यू क्या है, मिनिमाइजर है एनर्जी फंक्शनल का, तो अगर आई यू मिनिमाइजर है एनर्जी फंक्शनल का, सो यू हैव टू शो दैट u इज द सॉल्यूशन ऑफ दिस बाउंड्री वैल्यू प्रॉब्लम, ओके. So this is the Dirichlet principle, right? Again you listen, if u is the solution of this boundary value problem, so IU will be the minimizer of that functional. Converse, if IU is the minimizer of that functional, so you have to show that u is the solution of this boundary value problem, right? So this thing I have to prove. Now first I suppose that u is the solution of the given boundary value problem. So I take u belongs to c square u bar is the solution of boundary value problem, delta u equal to minus f in u and u equal to g on the boundary, right? Now here you can see that u is equal to g on the boundary and u किससे belong कर रहा है आपका, c square u bar से. So here you can see the definition over here. What is a? a क्या था यहाँ पे कि जो भी फंक्शन सी स्क्वायर यू बार से बिलोंग कर रहे हैं और बाउंड्री पर किसके इक्वल है, जी के इक्वल है, तो वो किस में जाएगी, फंक्शन सभी ए में जाएगी. सो ओवर हियर आल्सो यू कैन चेक दैट if u is equal to g on the boundary and u belongs to c square u bar, so that means u belongs to a. Okay, if u is belongs to a, so you say that iu belongs to I of a, where I is I of w, where w belongs to a, right? So that means iu belongs to ia, right? So अगर iu इससे बिलोंग कर रहा है तो a के सभी वैल्यूज पर हम i की वैल्यू निकाल लेंगे और वी विल हैव टू प्रूव दैट कि iu आपका क्या है, मिनिमम है. यू हैव टू शो दैट. सो दैट मीन्स व्हाट इज आवर क्लेम, our claim is that iu is less than equal to iw for all w belongs to a, right? What does it mean? That means iu will be the minimizer of the energy functional I, right? So what I take w be the any arbitrary in a, so I'll take this one. Then if w belongs to a, so does it mean, that means w belongs to c square u bar and w equal to g on the boundary of u. So if I say u minus w, if I talk about u minus w, so what is u? U is equal to g on the boundary, and what is w? W equal to g on the boundary. So that means u minus w अगर boundary पे बात करें हम, तो u minus w will be g minus g on the boundary. That means u minus w will be 0 on the boundary. Okay, and हमें क्या given है, delta of u will be equal to minus f in u, right? So you can say that अगर delta u को right side में transfer करें, so that means minus delta minus f, minus delta u minus f will be equal to 0 in u. Okay, so in this way we can say that integral of minus delta u minus f into u minus w will be equal to 0 in u. Okay, you already know that this minus delta minus u or minus delta u minus f is 0 in u, so that means their product and their integral, that will be equal to 0, right? Now just open this one. When I open it, it will be minus delta u into u minus w minus integral of minus f into this u minus w, that will be equal to 0, right? Now again we have to apply that formula as we have discussed above. What it says? It says that u into delta v in u, that will be equal to integral over the boundary minus integral over u, and what it was, that was u into curl v over curl nu, right? And minus of, when you are taking the integral in u, that will be du into dv, right? It was this one. So what is curl v over curl nu? By the definition we know that this curl v over curl nu is dv into nu, directional derivative of v in the direction of nu, so it can be written as dv dot nu. Okay, this term. So this is u into this one, right? So we are using this definition. The by same formula is there. U into delta v equal to integral over the u boundary of u, that will be u into curl v over curl nu, but curl v over curl nu is dv dot nu, ds minus integral of u will be du, first derivative first into derivative second, du dot dv. So now we are applying the same one over here. So over here you can say that what is u here, that is the first function and this is the second, delta of u. Actually this is first is simple and delta of u is second. Okay, so minus taken, you are just outside, so we apply this one. So when we take this one, so you will say that integral over the boundary and minus integral over u. So minus is here and minus minus plus, that becomes plus. Okay, because there is a minus sign here, this is minus sign, right? So what I says here, the same, this first as it is, so I will take this first as it is, and the second one is delta u. So delta u को हम क्या लिखेंगे, जैसे delta v को लिखा dv dot nu, so it will be du dot nu ds. So plus what is this one over the u when you take, so that will derivative first into derivative second. So derivative first will be d of u minus w, and derivative second will be into dw, right, dx, and minus of that term as it is, right. So we can say that, as we have already shown, कि u minus w क्या है, जीरो है on the boundary, because u भी आपका क्या था, g था बाउंड्री पर, और जो w था वो भी क्या था, g था बाउंड्री पर. सो दैट मीन्स अगर मैं बाउंड्री की बात कर रहा हूँ, सो ऑन द बाउंड्री दिस विल बी equal to g minus g, and that becomes 0. So u minus w is 0 on the boundary. So this is on the boundary we are talking. So this will be 0. So that means this part vanishes. So when this part is removed, we are left with this one and this one equal to 0. This minus this will be equal to 0. Now just simplify it. We will write down. It will be, just open dw minus dw. So yeah, du dot du minus dw dot du, right, and just open it, and we combine the integral over the u, that will be minus uf plus wf equal to 0. Okay, now I combine this one. This is, what is this one, du dot du, that will be mod du square, and with this one I combine this one, minus of uf. So I take integral over u mod du square minus uf dx, right, and minus the remaining term is this one and this one. So I take integral over u dw dot du and plus integral over u wf equal to 0, alright, which can be rewrite as, that will be equal to, transfer this both term to the right hand side, this minus this. Okay, but we know one result at mod of a dot b is less than equal to mod a mod b. Okay, so I'll say that if I take its mod value, so I'll say that this I am taking the mod value of du dot dw. So du dot dw is less than equal to mod of du and into mod of dw. And if I use the Cauchy inequality, so by the Cauchy inequality we know that, what it says, that Cauchy inequality says that a dot b is less than equal to a square by 2 plus b square by 2. Okay, so in the same manner we will use over here, that is mod of du dot dw, that is less than equal to half of, means mod of du square by 2 plus mod of dw square by 2, and this is a small proof is given in the right hand side. If I take mod of a minus b square is greater than equal to 0, a minus b dot a minus b is greater than equal to 0, so that can also be written as a dot a minus b minus b dot a minus or plus b dot b is greater than equal to 0, which can be rewrite as mod a square, this is mod a square, this is mod b square, and this is minus a dot b, right. And when we are minus 2 a dot b is transferred to the right hand side, or you can say that the adding 2 a dot b both sides, so you will get mod a square plus mod b square greater than equal to 2 a dot b, or you can say that 2 a dot b is less than equal to mod a square plus mod b square, and divided by 2 both sides, so you will say that a dot b is less than equal to this one, and mod of a dot b if I take, that will be further less than equal to mod of a square by 2 plus mod of b square by 2. Same. So similar we are saying that mod of du dot dw is less than equal to mod of du square by 2 and mod of d, right. So you will get this thing. Now if we are talking about this term, you don't have the w over here, mod here. So if I say that integral over u of dw dot du, that will always be less than equal to its mod value. Okay, so dw dot du को हमने क्या लिख दिया, du dot dw, that value is less than equal to its mod value. Okay, and you know that mod of the integral is less than equal to the integral of their mod, so I will take it is less than equal to this one. And above we have shown that this mod of this one, mod of du dot dw is less than equal to mod of du square by 2 plus mod of dw square by 2. So same thing, this value is further less than equal to mod of du square by 2 plus mod of dw square by 2, right? So I'm taking the mod in this value. So when I take, so you'll say that when I using this value, we have shown that this value is less than equal to this value. So this equation 8 I am using over here, over in the 7. तो ये वैल्यू हमारी क्या है, this value is less than equal to mod of dw square by 2 plus mod of du square by 2, right? So I am using over here. So you will say that this value is less than equal to, इसकी वैल्यू प्लेस करेंगे minus this term, right? So in the 7 I am using the 8. So you will get this one, mod of du square minus uf on u is less than equal to this minus wf. Alright, now if I take the integral of individual over here, so that will be mod of this one and plus mod of this one. So I transfer this term to the left hand side. So when I transfer this term to the left hand side also, I get this term is it is, and it is minus of half mod du square in u, and this is less than equal to, for the left part is this one and this one, right? So when I combine, this is integral over u and this is integral over u, so combine both integral. This is mod du square and minus half mod du square, so that will be half du, half mod du square and minus uf, right? And that is to the right hand side. If I combine the integral, that is half of mod dw square minus wf. So what is this one? According to the definition of the I of w. So what was that? That was half of mod of dw square minus wf, right, in u. So here also this is half of mod of d square minus uf in u. So what is this one? This is I of u. So this is I of u and this is the same one, बस u की जगह क्या है, w है आपका. So this is I of w. So what we got here, I of u is always less than equal to I of w. But what was w? W belongs to u was arbitrary. Or sorry, w belongs to a. W belongs to a was arbitrary. So that means for all w in a, I of u will be less than equal to I of w. So we will say that I of u will be the minimizer of the energy functional I, right? So you will get this one. It was arbitrary, so IW is equal to this one. So IW can be written as minimizer of the IW for all W belongs to A. Or we can say that W is the minimizer of the energy functional. Right. So we prove the first part. Now if we take the converse, so how to prove this one? Now we assume that u belongs to A and IU is the minimizer of the energy functional. So that means IU is minimizer of IW for all W belongs to A. What you have to show that? You have to prove that U is the solution of the given boundary value problem. And what was that? This is delta U आना चाहिए आपका minus F in U and U will be equal to G on the boundary. Okay. Now I suppose that W belongs to say infinite U bar, which is chosen arbitrary. But once chosen, that is fixed. And that notations we have already discussed in the previous lecture, you can see over there. So I assume that this W is arbitrary and we kept fixed. And we define that I tau will be equal to capital I of U plus tau W, where tau is any real number. Okay. So we can see that U भी आपका fixed है, W भी आपका fixed है. So that means that becomes a function of tau, right? So I, this is I of this, so I becomes a function of tau, right? If I becomes a function of tau, so you know that this since U is a minimizer function for the functional I, U आपका minimizer है for the functional I. So what does it mean? अगर U minimizer function है, so you will say that I of U plus 2W will attains the minimum at tau equal to 0. क्योंकि अगर tau equal to 0 आएगा आपका, तभी आपका I of U आएगा और I of U आपका क्या है, minimizer है. सो विल से दैट मिनिमाइजर फंक्शनल है अगर, क्योंकि हमें गिवन है कि आई यू इज मिनिमाइजर. सो आई यू अगर मिनिमाइजर है, ये कब होगा, जब दिस अटेन्स द मिनिमम एट टो इक्वल टू जीरो. दैट मीन्स ये पार्ट ना हो, राइट. सो विल से दैट एट टो इक्वल टू जीरो. सो डज इट मीन ये क्या है आपका, दिस इज स्मॉल आई एट टो. सो दिस हैज मिनिमम एट टो इक्वल टू जीरो. Okay. So also we know that the necessary condition for the I of tau to attain minimum at tau equal to 0, what does it mean? It will be, its first derivative will be equal to 0 at this value tau equal to 0. Okay. So that is the condition. So that means I dash tau will be equal to 0 at tau equal to 0. So what does it mean? That means I dash at 0 will be equal to 0. बट वट इज आई टो, आई टो इज दिस वन. सो पहले इसका आई डैश हम फाइंड आउट करते हैं, आई डैश टो. सो आई डैश सॉरी आई ऑफ टो इज कैपिटल आई ऑफ यू प्लस टी डब्ल्यू. सो कैपिटल आई की अगर मैं डेफिनेशन अप्लाई करता हूँ, वट इज दिस वन, इंटीग्रल ओवर द यू, दिस इज हाफ ऑफ मोड ऑफ डेरिवेटिव ऑफ यू प्लस टी डब्ल्यू स्क्वायर माइनस यू प्लस टी डब्ल्यू ऑफ इंटू एफ डी एक्स, राइट. आई एम जस्ट सिंप्लीफाइंग इट. So when you do simplify it, you will get, अभी तक हम आई टो को सॉल्व कर रहे हैं, राइट. सो इट इज हाफ ऑफ, इसे हमने लिख दिया डी ऑफ यू प्लस टी डब्ल्यू इंटू डी ऑफ डी यू प्लस टी डब्ल्यू डॉट एंड माइनस यू एफ माइनस टो डब्ल्यू एफ, राइट. दैट कैन बी रिटन एज हाफ ऑफ, just open it, this one, this will be dw plus tau, tau is common here, is scalar, and tau dw dot du plus tau dw minus uf minus tau wf, right. Further it can be written as, now you just open it, du dot this one. So when I take that du dot du plus tau scalar, so tau into du dot dw, right. Then this term with this bracket, you will get tau into dw dot du plus tau square into dw dot dw, right, and minus uf minus tau wf is written over here. So when I open again, you will get this one. So this term is mod du square and this term is mod of dw square, and this is 2 times. So it 2 tau dw dot du and minus remaining terms minus uf minus this, right. So which can also be written as half, just multiply in the terms in the bracket, you will half of mod of du square. So 2 will cancel out, tau into dw dot du. So half of tau square into mod dw square minus uf minus tau wf, right. It can also be written as, so अगर माइनस uf को मैं इसके साथ कंबाइन करके लिखता हूँ, so it is दिया हाफ ऑफ du square माइनस uf dx, ओके. एंड प्लस टो अगर मैं कॉमन लेता हूँ, एक इस टर्म में टो और इस टर्म में टो कॉमन लेते हैं हम, तो क्या होता है, टो dw डॉट du माइनस ऑफ wf इंटीग्रल, एंड रिमेनिंग टर्म आपकी ये बचती है. सो इंटीग्रल ऑफ यू ऑफ टो स्क्वायर बाय 2 mod of dw square, right. In this way we get. Now what you have to do, just you have to take the differentiation both sides with respect to tau, okay. So when you take the differentiation both sides with respect to tau, that will be, left hand side will be I dash tau, and when you take the differentiation with respect to tau, so there is no tau, so that means that is a constant term, so that derivative will be equal to 0, okay. So this term is removed here. So there is one tau, so when you take, so remaining term will be there, integral of u over this term, integral of u dw dot du minus wf will be remaining, and when you take its derivative, that will be what, it will be 2 tau by 2 into the remaining term dw square, so that means tau into mod dw square dx. अब हमें इस आई डैश टो की वैल्यू निकालनी है किस पर, एट टो इक्वल टू 0 पर. सो व्हेन आई टेक टो इक्वल टू 0, सो दैट विल बी आई डॉट I dash 0 will be equal to, यहाँ पर tau 0 है, so that is removed here. So when this term is removed, we are left with this one only, okay. So when you open this one, you can also see that that will be equal to dw dot du over u minus integral of wf over u, right. Now I'm using here this I dash, what was this? I dash 0. We have seen above that I dash 0 will be equal to 0. Okay, at tau equal to 0. Sorry, this is I dash. So this is equal to 0. If this is equal to 0, so you will say that mod of integral of dw dot du over u will be equal to wf integral over u, that will be equal. Right, now we know the result. Again that formula will be used as we have discussed before. What it says that integral of u delta v in u, that will be equal to integral over boundary minus integral over u, and what it was, that will be u into curl v over curl nu ds minus derivative of both du dot dv. ओके, बट नाउ वी नीड दिस टर्म, हमें इस टाइप की टर्म चाहिए अभी. ओके, तो अगर हमें ये टर्म चाहिए, सो व्हाट इट सेज, इसे लेफ्ट साइड में ट्रांसफ़र करो और जो ये टर्म है इसे राइट हैंड साइड में ट्रांसफ़र करो और इसे लेफ्ट साइड में. सो विल गेट दिस वन, इंटीग्रल ऑफ डी यू डॉट डी वी इन यू, दैट विल बी इक्वल टू यू इंटू कर्ल वी और कर्ल न्यू फॉर द बाउंड्री माइनस ऑफ यू डेल्टा वी एन यू. राइट, सो नाउ वी विल अप्लाई दिस फार्मूला ओवर हियर. राइट, सो हम ये फार्मूला अप्लाई करने जा रहे हैं. सो व्हेन वी यूज दिस फार्मूला, सो यू कैन सी दैट व्हाट इट सेज, ये टर्म आपकी किसके इक्वल आएगी, इसी के अकॉर्डिंग देख सकते हो, दैट विल बी इक्वल टू फर्स्ट इंटू कर्ल वी ओवर कर्ल न्यू. तो ये किसके इक्वल आएगा, डब्ल्यू इंटू कर्ल यू ओवर कर्ल न्यू ओवर द बाउंड्री. सेकेंड टर्म क्या है, माइनस इंटीग्रल ओवर यू minus integral over u, that is the first one, into delta of v. So first one is w into delta of u, right, and minus wf over u is written over here. So when we are applying this formula, we get this term. So we will get this term. Right, now what is curl u over curl nu? So by the definition it can be written as, that will be du dot nu. So it is du dot nu, and what it will be, that is integral of u. If we combine this integral, so it will be w delta u plus wf, ds will be equal to 0. Right, so over here you check that when u belongs to a, so if u is belongs to a, so what does it mean, u will be equal to 0 on the boundary. If u equal to 0 on u equal to g on the boundary, so g is fixed here. So if there is a fixed constant, so derivative of u, if you find out, so derivative of u will be equal to 0 on that boundary. Okay, if d of u will be equal to 0 on the boundary, so there is du. So if du is 0 on the boundary, so that term removed. So if that term is removed, we are left with only the second term. Okay, so we have only this term. So w is taken common, that is minus of delta u plus f into w, that will be equal to dx will be equal to 0. But what is this? If minus multiply both sides with negative sign, we will get this one. But w is what? W is arbitrary. If for all w, integral of this term into this term is equal to 0, so what does it mean? That means ये term आपकी क्या होगी, 0 होगी. Right? So if w is arbitrary, so I will say that if this term equal to 0 for all w belongs to cc infinity u bar, so you will say that delta of u plus f, that will be equal to 0 in u. If delta of u plus f equal to 0, so delta of u will be equal to minus f in u. Okay, और u आपका a से बिलोंग कर ही रहा था, जो हम सपोजिशन कर चले थे. सो अगर u बिलोंग्स टू a, सो दैट मीन्स u किसके इक्वल होगा, बाउंड्री के इक्वल होगा, और सॉरी u g के इक्वल होगा बाउंड्री पर. सो यू कैन सी दैट कि delta of u equal to minus f in u and u equal to g on the boundary. So that means we satisfy the this u satisfy the given boundary value problem. So अगर u satisfy कर the boundary value problem को, that we have to prove. Okay, यही हमें prove करना था. So we prove the converse part. If u is the minimizer of the energy functional, so that means u satisfy the given boundary value problem. So that was the डिरिचलेट प्रिंसिपल. ओके, सो जो हमने प्रूव किया. सो द नेक्स्ट टॉपिक वी विल डिस्कस इन द नेक्स्ट क्लास. थैंक यू वेरी मच स्टूडेंट्स.